Okay, hi everyone, welcome back to this live stream for Windows Server 2003. Just want to share my screen. Okay, the boot file. Consider what a primary DNS server must do when it boots. It has to configure out what zones it's supposed to be serving, decide whether it's authoritative for any of them, and link up with the other servers in the zone. If any, you can choose the method by which Windows Server 2003 DNS servers get this information from AD from the registry or from a bind style boot file. The boot file, which must be named system root /system32 /DNS /boot, controls the DNS server startup behavior. Boot files support only 4 commands. Directory. The directory command specifies where the other files named in the boot file can be found. This is almost always system root /system32 /DNS directory. You use the command along with the directory path like this: directory f : /wint /system32 /DNS cache. The cache command specifies the file of root hints used to help your DNS service contact name servers for the root domain. This command and the file it refers to must be present. For example, cache.dns points the DNS server as the as the default cache.dns file shipped with Windows Server 2003 primary. The primary command specifies a domain for which this name server is authoritative, as well as a database file that contains the resource records for that domain. You can use multiple primary commands in a single boot file. Here are a couple examples: primary chalice.net, chalice.net.dns, primary hsv.chalice.net, hsv.chalice.net, secondary. The secondary command designates a domain as being one that your server handles as a secondary domain. That means your server is authoritative, but it pulls DNS information from one or more of the specified master servers. The command also defines the name of the local file for caching this zone. Multiple secondary command records may exist in the boot file. The secondary command takes 3 parameters as shown by the following syntax: secondary domain, master server, local file for caching. Secondary entries would look like this: secondary woluka.com, ns.pair.com, woluka.dns, secondary chalice.com, ns2.pair.com, chalice.dns. How DNS resolves names. There are 3 types of queries that a client can make to a DNS server: recursive, iterative, and inverse. Remember that the client of a DNS server can be a resolver, what you'd normally call a client, or another DNS server. Iterative queries are the easiest to understand. A client asks the DNS server for an answer, and the server returns the best answer. This type of query is typically sent by one DNS server to another after the original server has received a recursive query from the resolver. The server may not know the answer and may direct you to another server, or it might respond with an actual or. Most resolvers, however, use recursive queries. In a recursive query, the client sends a query to one name server, asking it to respond either with the requested answer or with an error. The error states one of 2 things: that the server can't come up with the right answer, or that the domain name doesn't exist. The name server isn't allowed to just refer the client to some other name server. In addition, if your DNS server uses a forwarder, the requests sent by your server to the forwarder will be recursive queries. Figure 6.2 shows an example of both recursive and iterative queries. In this example, a client within the Microsoft Corporation is querying its DNS server for the IP address for www.whitehouse.gov. Here's what happens to resolve the request. The resolver sends a recursive DNS query to its local DNS server asking for the IP address of www.whitehouse.gov. The local name server is responsible for resolving the name and cannot refer the resolver to another name server. The local name server checks its zones and finds no zones corresponding to the requested domain. 3. The root name server has authority for the root domain and will reply with the IP address of the name server for the gov top level domain. 4. The local name server sends an iterative query for www.whitehouse.gov to the gov name server. 5. The gov name server replies with the IP address of the name server servicing the whitehouse.gov domain. 6. The local name server sends an iterative query for www.whitehouse.gov to the whitehouse.gov name server. The whitehouse.gov name server replies with the IP address corresponding to www.whitehouse.gov. 8. The local name server sends the IP address of www.whitehouse.gov back to the original resolver. So you can see here, figure 6.2, a sample DNS query. Inverse queries use PTR records instead of supplying a name and then asking for an IP address. The client first provides the IP address and then asks for the name. Because there's no direct correlation in the DNS namespace between a domain name and its associated IP address, this search would be fruitless without the use of the inaddr.arpa domain. Nodes in the inaddr.arpa domain are named after the numbers in the dotted octet representation of IP addresses. Because IP addresses get more specific from left to right, the domain names get less specific from left to right. The order of IP address octets must be reversed when building the inaddr.arpa tree. With this arrangement, administration of the lower limbs of the DNS inaddr.arpa tree can be given to companies as they are assigned their class A, B, or C subnet address. Once the domain tree is built into the DNS database, a special pointer record is added to associate the IP address to the corresponding host names. In other words, to find a host name for the IP address 206.131.234.1, the resolver would query the DNS server for a pointer record for 1.234.131.206.inaddr.arpa. If this IP address was outside the local domain, the DNS server would start at the root and sequentially resolve the domain nodes until arriving at 234.131.206.inaddr.arpa, which would contain the PTR record for the desired host. You have several specialized options when you configure DNS resolution as shown in the following sections: caching and time to live. When a name server is processing a recursive query, it may be required to send out several queries to find the definitive answer. Name servers are allowed to cache all the received information during this process. Each record contains something called a time to live TTL. The TTL specifies how long the record will be valid until it must be resolved again. The name server owner sets the TTL for each RR of their server. If your data changes a lot, you can use smaller TTL values to help ensure that data about your domain is more consistent across the network on which the name server resides. However, if you make the TTL too small, the load on your server will go up. That's because once data is cached by a DNS server, the server begins decreasing the TTL from its original value. When it hits 0, the server flushes the RR from its cache. If a query comes in that cannot be satisfied by this cache data, the TTL that's returned with its equal and current amount of time left before flush time. Client resolvers also have data caches and honor the TTL value so that they know when to flush. Load balancing with round robin and NetMask ordering. The Windows Server 2003 implementation of DNS supports load balancing through the use of round robin and NetMask ordering. Load balancing distributes the network load between multiple network cards if they are available. You can create multiple resource records with the same hostname but different IP address for multi-homed computers. Depending on the options that you select, the DNS server will respond with one of the multi-homed computer addresses. If round robin is enabled, the first address that was entered in the database is returned to the resolver and then sent to the end of the list. The next time a client attempts to resolve the name, the DNS server will return the second name in the database, which is now the first name, and then send it to the end of the list, and so on. If NetMask ordering is enabled, the DNS server will use the first address in the database that matches the subnet of the resolver. If none of the IP addresses match the subnet of the resolver, then the DNS server reverts to round robin. If round robin is disabled, the DNS server simply returns the first IP address in the database. If neither round robin nor NetMask ordering is enabled, the DNS server always returns the first IP address in the database. This usually isn't very helpful, so fortunately round robin and NetMask ordering are both enabled by default. You will see how to enable and disable round robin and NetMask ordering in the section titled Configuring Advanced Properties Bind Options. Earlier, we briefly hinted that bind is a simple DNS implementation primarily used by Unix servers. This is true to an extent, but bind is really just a set of RFCs that standardize the way DNS operates. Windows Server 2003 is actually compliant with several versions of bind, specifically bind 4.9.7, 8.1.2, 8.2, and 9.1.0, which makes the Windows Server 2003 DNS implementation interoperable with other bind DNS servers. Windows Server 2003 DNS can also be used on the internet because bind is a standard for DNS on almost every computer on the planet. We don't need to get into the specifics of the different versions of bind, but you should understand the two key points: how bind can affect your Windows Server 2003 environment. When Windows Server 2003 sends a zone transfer to a secondary DNS server, it sends several compressed resource records simultaneously. Unfortunately, bind versions prior to 4.9.4 don't support compression, and they can only receive one or at a time. If your secondary servers are running older versions of bind, you will need to disable these features, as you will see in the section titled Configuring Advanced Properties. Active Directory requires DNS and bind version 8.1.2. Usually you should use Windows Server 2003 DNS servers with Active Directory integrated zones, but some companies have long established Unix-based DNS servers that they need to continue to use. You may need to upgrade these servers if they don't meet the minimum bind requirement and you want to use Active Directory. So I'm going to leave it here this evening for this live stream. Thanks for spending the time with me and have a nice evening.